Okay, so I'm going to be doing 14.56. That is right here. Oh my gosh. And it reads, a 1.8 kilogram monkey wrench is pivoted 0.25 meters from its center of mass and allowed to swing as a physical pendulum. The period for small angle oscillations is 0.940 seconds. And the first part of the question, A, what is the moment of inertia of the wrench about an axis through the pivot? And B, if the wrench is initially displaced 0.4 radians from its equilibrium position, what is the angular speed of the wrench as it passes through equilibrium position? Okay, so let's see. So the distance of the monkey wrench from its center of mass is 0.25 meters. And then the mass of the monkey wrench is mass equals 1.8 kilograms. And then the period is 0.94 seconds. And then it also gives us the starting angle of 0.4 radians. And then let's see part A. So the period of wrench rotation about the axis through the pivot point is given by T equals 2 pi root moment of inertia divided by mass, gravity, which is denoted by 9.8, and then distance from the center of mass. And with some rearranging to solve for the moment of inertia, I get that I equals m times g times d times t squared divided by 4 pi squared. And then I just plug in all the numbers that were given to us. This is pretty simple. So I do 1.8 times 9.8 gravity times 0.25 times 0.94 squared. 0.94 squared, all divided by 4 pi squared. And then if you just run that through a calculator, you get that the moment of inertia is 0.0987. And that concludes part A. And for part B, hang on, let me erase all this. For part B, so now we know that the rotational kinetic energy is given by, let's see, K-E, rotational, equals 1/2 moment of inertia, angular momentum, squared. And then potential energy is given by mass, gravity, distance. 1 minus cosine theta. For the wrench, the angular speed will be maximum as it passes through equilibrium. So I use 1/2 I W squared max equals mgd 1 minus cosine theta. And then I just rearrange it to solve for this. And I get that the angular speed, the max angular speed, is equal to root 2 mass, gravity, distance, 1 minus cosine theta divided by the moment of inertia, which we found in part A. And then just to plug everything in, all the stuff that we were given, that would be root 2 times 1.8 multiplied by gravity, 9.8 times 0.95, and then 1 minus cosine 0.4 radians, all divided by, it's kind of messy, 0.0987 from what we found in part A. And then if you do those calculations, you get that the max angular speed is 2.66 radians seconds. There it is.